Today's notes are on inverse matrices, and I've got this system of equations to solve to start. Now, we're actually not going to solve this right now. Let's just talk about the ways we know that we can solve this. We could solve this by, first of all, probably the easiest way we know is to enter all of these into a matrix and get it into reduced row echelon form. We could also solve this by using row operations to try to solve for x, y, and z. We're going to talk about a new method to solve these. This method, in some cases, is easier than anything we've learned before. So let's start slow. Let's get into a different topic here. First of all, we've got two matrices here. Show that the first one is the inverse of the second one. Now, inverse matrices means that if we multiply these together, we get the identity matrix. So if I write down this first matrix, 1, negative 2, 1, negative 1, and the second matrix, negative 1, 2, negative 1, 1. And if we multiply, and remember to multiply, we use rows of the first and columns of the second. If these are inverses, the answer will be the identity matrix. So let's find out here. So top row, first column, we get negative 1 plus 2. Top row, second column, we get 2 minus 2. Bottom row, first column, negative 1 plus 1. And bottom row, right column, we get 2 minus 1. So, yes, these are inverses. Now, guess what? It doesn't matter what order you multiply them in. So if I would have switched these around and multiplied, I'd still get this identity matrix, which is 1, 0, 0, 1. Okay, so that's what's true about inverses. So that leads us to the next thing. How do you find an inverse? So if we're given a matrix, how do we find an inverse? Now, there's a bunch of different ways we could do this. There's some shortcuts that only work for 2 by 2 matrices. So I'm going to avoid those shortcuts simply because there is no one shortcut that works for all matrices. Okay, and because of that, I'm going to talk about a method that works for all matrices. Here's how you can find an inverse. First thing we do is we write the matrix that we have. But then next to that matrix, we also include an identity matrix. Now, we want to use row operations like we've done in the past to achieve this goal. We want to get a matrix that looks like this, that has that identity matrix to start, and then the numbers that appear over here on the right will be the inverse of the original matrix. Okay, so kind of thinking before, we want to work counterclockwise. We've got a 1 in the upper left corner. That's good. So the next step is to try to get a 0 in this spot. And to do that, we can multiply the top row by negative 2 and add that to the bottom to give us a new bottom row. So I'm going to keep the top row as is. 1, 4, 1, 0. Then 1 times negative 2 is negative 2 plus 2 is 0. 4 times negative 2 is negative 8 plus 9 is 1. 2 times negative 2, or excuse me, 1 times negative 2 is negative 2 plus 0 is negative 2. 0 times negative 2 is 0 plus 1. Okay, so now we have a 1 in that first spot, 0 in the next spot. Hey, we also have a 1 in this spot, so now we just need to get a 0 in this spot right here. So if we multiply the bottom row now by negative 4 and add that to give us a new top row, we should be good to go. So I'm going to keep the bottom row as is. In our new top row, we get 0 times negative 4 is 0 plus 1. 1 times negative 4 is negative 4 plus 4 is 0. Negative 2 times negative 4 is 8 plus 1 is 9. 1 times negative 4 is negative 4 plus 0 is negative 4. Okay, we have achieved our goal. So what does that mean? Well, it means that the inverse now is going to be this matrix with those 4 numbers. 9, negative 4, negative 2, and 1. Now here's how we could write that. If the original matrix, let's call it A, the inverse matrix we can write this way. It's A, it looks like A to the negative 1 power, but we would read that the inverse of matrix A. Okay, let's talk about another kind of problem. Oh my goodness. Now, to find this inverse, we could go through the same process, but at this point I'm thinking, come on, we've got graphing calculators. There's got to be a shortcut to doing this. So I'm going to pull my graphing calculator out. And if we enter this matrix into our graphing calculator, I actually have already done that. So matrix A is already in there. It's already this matrix that we've got. Okay, so I'm going to quit and get to our home screen. Here's how we can find the inverse. We can get the name of matrix A onto our home screen, and then this key right here, x to the -1, that's our inverse key. So when I type that, here's the command I get. When I hit enter, it gives me that inverse right away. So let me get that. And there's my inverse matrix. So if I have a more complex matrix, hey, I would just use my calculator. 2 by 2 matrix, we should get used to doing those by hand. Okay, well that wasn't so bad, was it? Okay, let's shift gears a little bit. Next example, directions are to solve this. Now, I'm not putting this in here because it's new. I know everyone knows how to solve this equation. We could divide both sides by 4. I know the answer is 5. I'm not concerned with that. Let's just think of it a different way. Now, when we solve this, if you think back when you first took Algebra 1, before you knew much about solving, we knew that, hey, we have 4 times x, so we need to do the inverse operation, divide both sides by 4. Now, another way of thinking about that is, let's multiply by the inverse of 4. Let's multiply both sides by 1/4. If we do that, we get x by itself. A fourth of 20 is 5. We get our answer. Here's the key, though. We multiplied both sides by the inverse of this number, and that gave us our answer. Now, let's keep that key in mind because we're going to use that method to solve more complex equations involving matrices. So let's say I have this system of equations here. Here's another way we can write this. We can say, okay, let's write just these coefficients as a matrix. 1, 4, -1, and -3. If we multiply those coefficients by x and y, we will get the answer, or the solution, and I'm leaving space for a reason, 2 and 1. Okay, here's the deal. Just like the last problem, if I multiply what's on the left by the inverse of this matrix, this will be gone completely. I'll have just x and y by itself. Now if I multiply what's on the right by the inverse of that matrix, I'll get the solution. So kind of like this example, if we multiply by the inverse on both sides, we get our solution. Same thing here. So what we need is the inverse of this matrix here, 1, 4, -1, and -3. Okay, I found that inverse, so I'm going to save us a little time by just writing what that inverse is. So I'm just going to call this matrix A. If we multiply by the inverse, so I'll put A -1 here, or A, the inverse of matrix A. If we multiply by the inverse of matrix A on both sides, on the left, A and the inverse of A, that's just 1, so that'll be gone. And on the right, we'll have our solution. Okay, so that inverse, like I said, I already figured it out to save us time. If you want to plug this in your calculator, let it figure it out for you, that's perfectly okay. But we get -3, -4, 1, and 1. Okay, and anything we do on the left side of the equation, we need to do on the right side. So all right, so on the left side now, if we multiply these matrices, we'll have the identity matrix. So that means x and y, our answer is going to be what we get when we multiply on the right. So remember, when we multiply, we're going to think rows of the first matrix and columns of the second matrix. Okay, if we do that, top row, first column, -3 times 2 is -6, -4 times 1 is -4, that gives me -10. Bottom row, 1 times 2 is 2, 1 times 1 is 1, put those together, we get 3, and there's our solution. X and y are equal to -10 and 3. So this just gives us another method for solving systems of equations. We now know we can solve systems We could have solved this by graphing, by substitution, by addition. We could have used a matrix with reduced row echelon form. We can also use this method, solving by using an inverse. Now, if we think about a more complex problem, so this is the first example I gave you. This is about as complex as it gets. How can we solve this using an inverse? Well, I'm going to let my calculator do the work for me. So what I have done is I actually typed all of this in for matrix B. So if I look at matrix B, there's these coefficients. Okay. All right. I'm going to do something else here. So in matrix C then, I'm going to edit matrix C, and I'm going to put the solutions in for matrix C. Now matrix C, there's going to be 3 rows and 1 column. That's not what I meant. Let's go 3 rows. Let's try that again. And 1 column. There we go. Let's put these answers in here. So 6, -5, and -16. Okay, so here's what I've done. Let's go back to this. So B is all these coefficients. C is the solutions. So right now we have this. We have B times the variables, which I'm just going to call x, equals C. Now if we multiply both sides of the equation by the inverse of B, on the left side they'll be gone. We'll have x by itself. On the right side we'll have the answer. All right, let's see how easy that is using our calculator. So I'm going to get back to my home screen. And then let's just type on our home screen. I'm going to get the name of matrix B. And I'll get the inverse of that. But I want to multiply that by matrix C. So I'm just going to get the name of matrix C. So inverse of matrix B times C, that's exactly what we had right here. Let's hit enter and it will do that work for us. And there's our solution. Hey, that's a relatively quick and easy way to get that solution. So what we have for x, y, and z is -37 for x, -9 for y, -52 for z. That is a whole lot easier than trying to solve using some other methods. So multiplying the inverse of the first matrix by the solution matrix will always give us our answer for x, y, and z. And keep in mind this will work for more complex systems of equations as well. All right, let's practice that a little bit. Okay, for simpler matrices like 2 by 2s, practice doing that by hand. For more complex matrices, so 3 by 3 and up, go ahead and practice using your calculator with that.